My project is, what is the effect of glucose and aspartame on the longevity and reproduction rate of a C. elegans? Obesity and diabetes are an enormous problem in the United States. High sugar consumption has been associated with a rise in these diseases, as well as other health problems like heart disease, strokes, and dementia. Alternatives to sugar have been developed, including one of the most popular being aspartame, which is the main ingredient to Equal and NutraSweet. I was interested in this because I see a lot of products every day claiming that they are better for you because they don't contain any sugar. Some studies have shown that high intakes of dietary soda does not result in weight loss. My hypothesis is when aspartame and glucose are added to a C. elegans plate, the different concentrates of aspartame and glucose will decrease the longevity and reproduction rate of C. elegans cultures when compared to a control plate. The reason I think the control plate will do the best is because when aspartame is metabolized, there's a part that gets broken down into methanol, 10%. Methanol is toxic to humans in large amounts, and I believe that C. elegans will die due to its toxicity. For this project, I used different concentrates of glucose and aspartame, varying between 15 millimoles per liter, 30 millimoles per liter, and 45 millimoles per liter. I placed these different concentrates on plates containing C. elegans and E. coli, which is the food source for the C. elegans. For the control plate, I added luria broth on the plate with the C. elegans and E. coli, and then I sealed all the plates up. For 2 weeks, I looked at them under the microscope and recorded how many I saw. I also looked at them every day to see if they were still alive, and I recorded the day the plate died. The results shown that the C. elegans on the control plate lived the longest out of all these groups, with a lifespan of 22 days. The worms on the glucose plate lived for 19 days, 21 days, and 20 days, respectively, for concentrates of 45 millimoles per liter, 30 millimoles per liter, and 15 millimoles per liter of glucose. The worms with the shortest lifespan were the worms on the aspartame plate. They lived for 11 days, and 15 days, respectively, for concentrates of 45, 30, and 15 millimoles per liter of aspartame. The number of worms per plate were also calculated by the first 14 days of the experiment. The number of worms per plate were not significantly different between the groups for the first 6 days. The glucose plates were similar to the control plates by having an average of 20 worms per day during the subsequent days. In conclusion, my hypothesis was supported. The control plate containing worms grown on standard growth medium lived the longest, followed by the glucose plates grown in glucose added to the medium. The longevity of the worms was concentration dependent. The higher the concentration, the shorter the worms lived. The worms grown on plates with aspartame added were the shortest lived and also showed this pattern. The results would support the conclusion that aspartame is toxic to C. elegans, and the toxicity is directly proportional to the concentration of aspartame. For the first 6 days, the total number of worms were similar in the group, suggesting that there was not much effect on reproduction rate. The limitations throughout this project were, when the C. elegans were plated, a block was placed on the center of each plate, and due to the large amount of liquid placed on the plates from the glucose and aspartame, the original chunking block began to slide around. This affected the data taken on the region spread too, and for the rest of the project, measures were taken to not disturb the placement of each block. Also, due to the amount of liquid on the plates, the amount of eggs counted could not be collected because the eggs were mixed in with the liquid and they were unable to be clearly identified. It was also assumed that all C. elegans were the same age and health when they were plated. The original idea on placing the chunk in the middle of the plate and recording the observations on how fast and how far the worms have traveled in a period of time using concentric circles moving away from the original chunk was a good idea. But there is no way for the chunk placed on the plate to stay in its original spot, and due to that, after a few days of observing the plates, it was noticed that the chunks had slid. In the future, if there is a solution to this problem, the data collected for region spread 2 would be more accurate. Thank you.